Um, Today I wanted to show you what I found under the hood in the Juicy Swap masterclass. So I'm gonna start where we deploy the contract with the migration file, the second one, where we actually deploy the token and the master chef contract, which is doing all the work. So we deploy the token right here and we assign it to sushi token. Then we deploy the master chef contract and we pass some arguments to it, like the sushi token address, for example, dev address, which should be your address, multi-signature they suggest here. And then we have the token per block reward that we're giving away. And after that, we have the start block when we're actually going to start minting rather than mining, minting tokens. And we also have the bonus and block. This is when you will no longer get the bonus for stacking under this pool. So we deploy master chef and then we transfer the ownership of the token to master chef. So master chef becomes the owner of sushi token, so he can mint some sushi token or whatever you call your token. This is like the actual Juicy Swap master, pretty much straight out of the box. And after that, it adds, this is where it adds, for example, DAI to the pool. So you add it from your .env file. You declare allocation point, which is, I kind of see it as a weight of the token on the pool. And then you declare the token address. So by adding it, you're actually calling your contract, your master chef contract here. So we're going to go inside this add function and see what happens with the actual contract. Master chef. So we add a token. So right here, we add a token, allocation point, the weight it has, kind of, the token that we declare as a IRC20, and the update Boolean. We'll see what it is later. Only owner can call this function. So add a new pool, a new token to the pool. And if you declare the Boolean as true, you will do a mass update to the pool, which might cost a lot of gas. You want to be careful about this one. We'll mention it later again. So how it goes, it will update the block in the pool for the rewards. So based on here it's we add a token, so we check if it's the start block versus the block number, and that's where it starts. You just add it, and this is where you allocate the allocation point to the total allocation point. So you add it to the total. So we'll do some math later with that. But let's start with the basic. This is where we actually push into the pool info the new token, LP token, that we pass to the function, allocation point, and these two, well, the last reward block, it's right here. And the accumulated sushi per share, you start off with 0. We'll see that later as well. So you add a token to the pool. So let's see what is the pool like. We see here we have pool info, and we push a struct in an array kind of thing. So our pool info array is right here, which is actually a struct with our token, allocation point, last reward block, and accumulated sushi per share. Okay, so that's how we keep track of this tokens pool. So this is how the owner of the contract adds a token, an ERC20 token, to the pool. Okay, we have the same model here. So this is what you're doing in your migration file. When you add a token, you provide the point and the address, and the function does the rest. And then false, because we're not going to do the mass update. It's only one token. And how does the update happen? Why am I not doing a mass update here? Because whenever we do a transaction, the pool will get updated. So let's see here, we have deposits and withdraws event, okay, with pools ID and an amount with the user. So let's actually take a look at these deposit, update pool, deposit, and withdraws. Okay, so here we deposit an amount to a pool ID. Okay, so a reference to our struct, an array where we pushed our token when we added it. And this is where you store the info on the user for that pool. I can do it another way, but we'll see it later. It kind of works no matter what. And here you update the pool. Now this is important because this is whenever you do a transaction and you spend gas doing so, might as well update your pool. So you call for this function, update pool, which is right up here. And this is pretty much where the magics happen, because you just provide the ID whenever you do a transaction on an ID. And you provide an ID, okay? And you do the math. Basically, you do the math, okay? You check for the reward based on the block number. So if this actual block number right now, it's smaller or equal than the last reward, there's nothing to do. It's been done. So you return. After that, well, if there's actually some reward, we check for the supply, which is basically the balance of your contract for this token, this provided token on the pool that you declare here, your storage in your array right here. So we check for the supply, okay? If the supply is 0, then the last reward was at least now. So there's nothing. It's been awarded. So we start, I guess, from now, because it's at 0. So there's going to be rewards from now on, and we return. Otherwise, no, that's actually where there is there's nothing to be shared over here. But if there is something, yeah, that's correct. If there is something, we'll get the multiplier. Okay, what's the multiplier? Well, you have this this option that's declared higher in your contract. You have the function that's actually calling for it, get multiplier. Okay, and it's getting the multiplier based on the bonus end block. So we have a bonus multiplier of 10, okay, that will get applied if you're participating in the pool before the bonus end block. Okay, so what does this function do? Okay, it gets multiplier. It checks whenever you withdraw your token. If you want, you add some token on the pool from that block to that block. So if you're before the end block bonus, then you'll get the bonus applied to the number of block you add token in the pool for. Okay, so this is your bonus multiplier of 10. So if you were in for one block, you get one block multiplied by 10. So you get a bonus of 10. Okay, and in some other case, you would get different bonuses. If you're past the bonus, and you don't get a bonus. Okay, otherwise you might be like, I think this is partially, you were partially in with the bonus kind of thing. Okay, so it will return your whatever bonus you get if you want. Okay, so if we go back to the update update function, sorry, update pool. Okay, we get it. Okay, let's say we add one block. We were in for one block and we had a bonus of 10 based on these two blocks. Okay, now from the last reward. Okay, we'll see it later in my test how it performed. So the reward would be the multiplier. Okay, here we have 10 multiplied by sushi per block, which I've set to 100. Okay, in your .env file. Okay, and then we multiplied by the pool allocation point. Okay, which is kind of the weight it has on the pool that you input when you add the token. The first unit value, unsigned integer value, is the allocation point on the pool, and divide by the total, because there's more tokens. Okay, so the total of them. So it's kind of a ratio on how much this token has weight, if you want, on the pool versus all the other tokens, and you apply the bonus to it, the sushi per block. So in our case, we add 10 by 100, so it's 1,000 sushis get produced here. Then multiplied by pool allocation, which was 1 in my case, so it stays 1,000, and there's only one coin with one allocation point, so the total is still 1 to me. Okay, so the reward is worth 1,000 right now in my case. So here dev adders get 10% of that reward, so 100. And here we mint the reward for the contract, because we haven't transferred it yet. We mint it, we give it to the contract, and then we set the accumulated sushi per share. Okay, we add to it, so we update it with this reward multiplied by, this is like 1 with 12 zeros, divide by the supply, which is right here, which is the balance of the contract. Okay, so not sure here what does this factor does to it yet. We'll see it later, but it gets applied to it and gets removed later on. Anyways, that's there. So that's what it's basing its reward on, if you want. And then it set the last reward block to this actual block, because we just gave away the award. We just minted some tokens. Okay, so this is how every time you make a transaction, everybody get paid. Well, at least the dev and the pool for now, because you may be making a deposit and run this function and actually pay the contract and the dev, but you're getting your token when you withdraw. So what I did, I took these core functions and I kind of use it my own ways. It's basically the same result, but I'm running tests against it. Okay, so here again in my test, the usual, I have my bonus end block, which I've set like pretty far just to do some maths. Start block is pretty much, I think, 0. My dev address, the token address, which I get from deploying the token right here. Okay, so I do the same in the test as the migration file. So we deploy, I call it stacking. Okay, with the token address, basically same arguments. Okay, it's a copy, and I transfer the ownership of the token to the stacking contract. And then I'm adding some tokens to the pools. Okay, so I'm looking at the pool balance. It should equal 0 because nothing happens yet. I add a token to the pool. Okay, this is how you had it in your test, just like you would pretty much in a truffle console or whatever you're using. Okay, it's you're calling your deploy contract stacking, the function add, the weight the token, the allocation point, the token itself, the address, and whether or not you're doing a mass update, which I'm not here. Okay, so I add my token, not dying, or I just added my token so I can mint some of my tokens by stacking my token. So that's the only token I add. In the pool, it will have the index 0 because it's the first one in the public info array, if you want. Okay, and here I'm gonna run some tests. Okay, just to basically confirm the maths behind this. Okay, so I have an amount, okay, of 100 tokens that I'm going to stack, and I have an ID. Okay, this is a pool ID. So I'm stacking, actually this is a before each. So before each async, all this is gonna happen. So I'm gonna stack 100 token. I'm gonna add the token to the pool. I'm gonna approve the contract to stack this amount. Okay, from that's actually me right now, the deployer deploying the contract, calling this. So from my account, and then it's going to stack token. Okay, the function is called stack token, but it would be deposit in your case on the original Juicy contract. But this is my own contract. I just changed the name of the function. So basically I stack some token. Okay, it's the same thing. And here, since I'm doing tests and I'm not sure what I'm gonna get as a block for the block number, I'm just getting whatever is happening on the blockchain, so I can't really test against it, but I'm logging it. So the last block reward on the before, for the before each, okay, before each async down here. So I know this is the one from before. So when we actually like stack some token before each test we're gonna run against it, okay? So here I'm stacking 100. I'm also the deployer, but the developer as well. So I'm the dev address. So I'm gonna check the stack that was just created in the pool. Okay, the pool here. It's the first stack on the first pool. So yeah, pool info is the first pool, ID of 0. Allocation point, that should equal 1. That's what we passed it. Token stack, this is the actual LP token for you guys. Should equal the my token address. I'm using the same token, so it's still the token address. And since I just deployed it, accumulated sushi share should be 0. And then we check the balance of the pool, okay? Because we just stacked 100 token. So the balance, okay, the token balance of the stacking pool, stacking address rather, should equal 100. So the balance is good. We checked the last reward block. Here I was running tests, trying to figure out where I'm at with the blocks. So I'm still on the same pool ID. I have my pool again, and I'm basically just logging whatever block I have last updated with, and the share I'm up to. But where it actually happened is here I check the balance of the dev address, okay? Because 900, because I minted 1,000 to the dev on deployment. So since I stacked 100, I should have 900 left, so that balance is good. So when we unstack token, we withdraw token. I'm checking the balances a lot. So the balance of the deployer should still be 900, nothing happened. And then I wait 20 seconds, okay, from the usual helpers file, okay, with a wait function. I wait 20 seconds, so I get at least a block further ahead. Okay, so I thought it was 13, but no, it ended up that this 20 seconds only one block. So if I go back to my pool and unstack from the pool ID 0, the first one, I unstack my 100 token from deployer on this pool. Okay, so now this pool last block reward and accumulated sushi per share in your case. Okay, get logged. We'll see it in a moment. And the balance of the deployer is back to 1,100. Why is that? So we had 1,000 on deployment. We stacked 100 down to 900. We took 100 back and we end up with 1,100. This is because in the update function, we gave 10%. We mint 10% to the dev. Okay, whenever we update pool, it's coming. We gave 10% of the reward, which was 1,000 based on 100 per block plus the bonus. So 10 times 100, it's 1,000. Dev gets 100. So this is why we end up with a balance of 1,100. So this is working. And we check for the balance of the contract, master contract. Now it's 1,000 because I did not withdraw. In my update, I did not, which is for me it's unstack token, but for you guys it's withdraw. I did not transfer, actually call this function safe transfer to message sender, depending, okay, pending reward. What's the pending reward? Okay, the pending reward, you guys, it's going to be user. Okay, this is going to reference to user, but me, I have some other setups, so I call it stackers. On the pool ID, this user, so this is the amount, this is equal to the amount that this user has stacked on this pool. Okay, multiplied by the pool accumulated sushi per share. Okay, and then we divide. Okay, it was added earlier to store it, and then we remove it here. Okay, so I'm really wondering what's the use for this factor right here. Okay, this 1 exponent 12, which is like 1 with 12 zeros. It's not decimals because it's it should be 18, so I don't really get it. If someone can find out what this means and why it's there, I'd like to know. So that's why the balance of the pool is still 1,000, because even if there was pending token, I did not transfer them. If I were to remove this comment right here, then the balance of the dev, because it's all the same person, dev, deployer, it's all the same address. It's all me that deployed and received the reward in stacks and everything. So I would end up with that extra 1,000 token that was minted during this one block with the applied bonus. Okay, so basically the bonus you stop getting it once the end block bonus block number is passed. Okay, so that's how it works. So in my test, let's bring out the test result. Okay, I had we checked the balance of the pool. We added a token to the pool. We stack some token, and we can follow the blocks here. Okay, the before, remember that before, it was like the before each async. So each of these result will be an async. Okay, so I just stack at block 577 and then I stacked it. I create a block, and then I did some more action, and then by the time these action gets done, we can see the blocks increase. Okay, what we're looking at is the fifth before 577 example, because in the test we're running before each async. Okay, so we have one async, 2, 3, 4, and 5. We get to the withdraw transaction where everything gets applied, it gets update, and everybody get paid. This is where it happens. So in the fifth before 1, 2, 3, 4, 5, we're at block 601, and we withdraw, we unstack at 602. So it's one block. With the bonus, you get a multiplier of 10. And then this is the accumulated factor that's getting stored with that one exponent 12 factor. I'm not sure why it's there. I'm investigating. So this is how it works. So if you're looking at it into adding a token, this is what you want to look at. Basically on deployment, you want to maybe add it on deployment. In the deploy contract, you can just run this, basically copy and paste this with different values, different location point and address to add some tokens. I went with the core, the contract itself, not the interface. I'm going to use my own, so this is why I'm not covering the interface part. Sorry guys, but I cannot cover it all. I'm not even done breaking this contract apart. So this is what I have so far. Hope you liked it, and I'll see you guys around. Thanks.